Good day everyone, welcome to today's session. In this session, we're going to do biology. Okay? We're going to do biology. And the topic we're going to cover is water and its properties. Okay, so this is what we're going to do in this session. So let's look at water. Okay, before we understand water and its properties, we need first to understand water itself. What is water? Let's look at the definition. So when you're talking about water, we need first to understand what makes water. Okay, this is the chemical formula of water and the inorganic property of water. So these two important things can help us define water. So what is water? This is H2O. We are going to look at the formula for us to define it, and we're also going to look at the inorganic property. So how do you define water? Water is an inorganic substance consisting of hydrogen and oxygen bonded together in the ratio of 2 to 1. So basically that's how you can define water. Now let's look at the ratio. We are saying it is bonded in the ratio of 2 to 1. Where is it coming from? As you can see here, there are 2 atoms of hydrogen and 1 atom of oxygen. So the ratio is simply 2 to 1. Okay? Now let's understand the bond in water. So this water is bonded, or there are certain bonds which are in water. So this, we have hydrogen here, we have oxygen. A bond which exists between this oxygen and the 2 hydrogen atoms is known as a covalent bond. So water is bonded by covalent bonds. Okay, now at this point, let's now understand something interesting here. Okay, let's understand this. The structure of water and how it is made. Okay, so let's understand the structure of water. So we are what is known as the dipole moment. We have what is called the dipole moment of water. Okay, let's understand this. So we have oxygen there, hydrogen there, hydrogen there. This water has some lone pairs on oxygen, so we have 2 lone pairs of oxygen there. So the thing I'm trying to outline here is that hydrogen is bonded together with oxygen by covalent bonds, but these electrons are much closer to oxygen and not to hydrogen. Why? Because oxygen is more electronegative. So we look at electronegativity. Oxygen is more electronegative. Okay? So we look at electronegativity. Electronegativity is simply the ability of a certain molecule to draw or pull a pair of electrons to itself. So these electrons are much closer to oxygen. They are pulled much closer to oxygen than to hydrogen. So to show that, we show using an arrow, okay? Like that. Meaning that our oxygen has pulled the electrons, the pair of electrons, much closer to itself than to hydrogen. In short, oxygen is acting selfish, okay, in this kind of scenario. Now, we are saying water is dipole. Let's look at dipole moment of water, okay? So we have a partial hydrogen there, and also another partial hydrogen there, okay? So, and oxygen, partial negative, partial negative. Okay, so let's understand something which is known as dipole. So, in talking about dipole, dipole is simply the separation of charge in a molecule. So, how the bonds are, when these two gets bonded, hydrogen, because hydrogen is not pulling much electrons, or electrons are pulled much to oxygen atom, oxygen develops a partial negative charge. Then hydrogen, the two hydrogen develops a partial positive charge. It is not like electrons are now in oxygen, or they are now bonded with oxygen. No, it is because there's just that strong attraction force of the electrons to oxygen as compared to hydrogen. As such, they develop what is known as partial negative and partial positive, and that is what we are calling dipole. So that is simply the dipole moment of water. And when you're looking at this, oxygen has two lone pairs, and these lone pairs are the ones which gives the shape of water, okay? And there's an angle between the oxygen atom and the two hydrogen atom, and that angle is equal to 104.5 degrees. So if they ask you what's the angle between the oxygen and the two hydrogen atoms, so the angle is 104.5 degrees. Now, let's understand the bonds. We can have water molecule here. This hydrogen bonded to another water molecule. This hydrogen also bonded to another water molecule. This oxygen bonded to another water molecule, and this oxygen, since it has lone pairs or two lone pairs, so it can be bonded to two oxygen, two water molecules. Okay, so we can see that that is a water molecule 1, that is another water molecule 2, that is a water molecule 3, and that is another water molecule 4. So we can say that this water molecule is able to be bonded to 4, or is able to form 4 hydrogen bonds. Okay, it is able to form 4 hydrogen bonds. Now let's look at the number of hydrogen bonds in liquid water and in solid water. Solid water is simply what you are calling ice. So in ice, water has the average of 4 hydrogen bonds, okay? But in liquid water, it has the average of 3.4 hydrogen bonds. Now let's understand why is it so. Because in liquid water, the hydrogen bonds are constantly forming and breaking, okay? But in ice, in solid water, the hydrogen bonds are not forming and breaking, but in liquid they are constantly forming and breaking. So it is very important to understand that, okay? Now let's look at the bonds which holds, if you have a water molecule here and another water molecule there. Okay, let's look at the bond between these two water molecules. So the bond between different water molecules is what is known as hydrogen bond. So what is hydrogen bond? Hydrogen bond is simply the dipole attraction of a hydrogen, a partial hydrogen atom, and another partial, very electronegative water molecule. For example, it could be oxygen, it could be nitrogen or fluorine. Okay, it could be oxygen, it could be nitrogen or fluorine. So that's where hydrogen bonds can exist. Now let's understand something here. So we can have hydrogen bonds oxygen there, this is a water molecule bonded to another water molecule. So this hydrogen bond, it is easy to separate it, but once they are many, so many hydrogen bonds are difficult to separate. Okay, when they are many, they are difficult to separate, but one hydrogen bond is a weak bond, and we can say that covalent bonds are much stronger than hydrogen bonds. Okay, covalent bonds are much stronger than hydrogen bonds. I'm using a greater sign there to show that they are much stronger. And we can see that this water molecule is able to dissolve other molecules. Okay, this water molecule is able to dissolve other water molecules. So, and different substances are able to get attracted to water. And what do you call a substance that attracts a water molecule, or a substance that is able to dissolve in a water molecule? That is known as hydrophilic. So we can say that water is hydrophilic. Hydro means water, philic means love. Okay, philic is just love, that attraction. Okay, that is what is known as philic. So what is hydrophilic? Hydrophilic is simply the love of water. Okay, so some substances are able to dissolve in water, and those substances are called to be hydrophilic. But there are some substances which are not able to dissolve in water. Okay, there are some substances which are not able to dissolve in water, so those substances are known as hydrophobic. They are not attracted to water, they are not able to dissolve in water. What does hydro mean? Hydro means water. What does phobic mean? Fear. Phobia is just fear. So they fear water. They're not attracted to water. So those substances are called hydrophobes. Excuse me for that. They are known as hydrophobes. Okay? So examples of hydrophobes could be fats. It could be oils. But these fats, when you look at fat acids have some parts which are hydrophobic, other parts are hydrophilic. Like the head of the fat, because of the presence of the phosphate ion, they are able to dissolve. That is hydrophilic. But the tail, due to many covalent bonds, okay, they are hydrophobic, okay, because of the carbon to carbon chain. Due to many carbon atoms, it is hydrophobic. And not a substance that is both hydrophilic and hydrophobic, that is called amphipathic. Okay, so when you're looking at a fat acid is amphipathic, but because of the tail, okay, the tail which is able not to dissolve in water, which is unable to dissolve in water, and the head which is able to dissolve in water. Okay, so the head is able to dissolve, but the tail is not able to dissolve in water. So that is what you need to understand there. Now let's now look at the properties of water and their importances. So let's look at properties of water and their importances. The first property we'll look at is known as cohesion. Okay? What is cohesion? Cohesion is simply the attraction of molecules of the same kind. Okay? The attraction of molecules of the same kind. So let me say cohesion here. The opposite of cohesion is the property number 2, which we are calling adhesion. So cohesion, we are saying the attraction of similar molecules. Okay, but adhesion, the attraction of what? Different molecules. Okay, now what is the importance of cohesion? We are saying cohesion is the attraction, like water molecule and another water molecule, but adhesion of different kind, like the water molecule and the vessel or the walls of the xylem. That is adhesion. Now what is the importance of cohesion? So cohesion and adhesion helps in transpiration. Okay, these two processes helps in transpiration. What is transpiration? This is just the loss of water by the plant through the stomata of the leaves. Okay, so they aid in what is known as transpiration. So for water to move or for water to be transpired, there has to be a force, the force which we are calling the transpiration pull. And that transpiration pull, how does it come about? It comes about due to a cohesion and adhesion. So the water molecules are able to stick to each other, that is cohesion, and they are able to stick to the walls of the vessel, that is adhesion. Okay, so we need to understand that clearly. Now let's look at this same adhesion and cohesion. So we can have these two test tubes, one with water and the other one with ethanol. So there is water here there is ethanol. Okay, let's understand something here. So this is what is known as the meniscus. Okay, so the meniscus in water is able to curve downward. You can see that there is a downward curve, but the meniscus in ethanol is able to curve upward. Now why is it so? Because in water the adhesive force are much stronger than the cohesive force. As such, they are able to make the meniscus of water to curve downward. But in ethanol, the adhesive force are less. stronger, or should I say the cohesive force are much stronger than the what? The adhesive force. And this is what gives the eternal meniscus to curve upward. So very, very important to understand that. Okay? It's very much important. But let's look at the way detergents are, or the way detergents operate when you put in water, or they work. Okay? So when you put a certain detergent in water, how is it that you are able to wash? We know that detergents are used for washing. Now, how are you able to wash? Or why is it difficult? Why is it difficult to wash without a detergent, without soap, without washing powder? Why is it difficult to wash a cloth? Like, the dirt won't come out, but once you put a detergent in the water, the dirt is able to come out. That is simply the action of the detergent, or the substances in that detergent, and on the adhesive forces. Okay, so we have to understand that the detergents are able to reduce the attraction of adhesion and reduce the attraction of cohesion. Okay, they reduce the attraction of cohesion and increase the attraction of adhesion. As such, they increase, in short, wetting. Let's understand what wetting is. Wetting, okay? When you put something in water, it is able to wet. Now, what is wetting? Wetting is simply the attraction of water to a solid substance. Okay? The attraction of water to a solid substance. And this is due to adhesion or adhesive forces. Of course, the cohesive forces also play a vital role in wetting something, but cohesive forces are able to make what? Droplets. Cohesive forces make droplets, but adhesive forces is the one which is able to make water to spread on a material. And we are safe to say adhesion is what brings about wetting, because water is able to spread on the surface of a liquid, and that results into wetting. Let's look at property number 3. Property number 3, which we are going to look at, is surface tension. And water has a high surface tension. Now, what is surface tension? Surface tension is the ability of water to form a thin layer on the surface. The ability of water to form a thin layer on its surface. That is simply surface tension. For example, if you have a sea, this is a sea, okay? Then water will form a thin layer. You know, some insects are even able to walk on water. They'll be able to walk on water due to this surface tension, okay? It can walk on water, and some things can even float on water due to the same surface tension. Okay, so surface tension is much important. All right, let's look at the fourth property. The fourth property is what we are calling capillary action. What is capillary action? Okay, so capillary action is the ability of water to rise against gravity along the narrow tube. If you have a tube here, we can have a tube here, a capillary tube, then which is placed in water like that. Okay, of course, it should just be partially placed in water. You discover that this water will begin to rise. Okay, will begin to rise to the top along the capillary tube against gravity. That is capillary action. And what causes capillary action? It is because of the cohesive force and adhesive force. So the water molecules are able to stick to each other, that is cohesive force, and they're able to stick to the walls of the capillary, that is adhesion. So this brings about capillary action, the action of the water to rise against the gravity along the capillary tube. Okay, and this helps in transpiration. So capillary action of water, or capillary action of water, can also aid in what? Transpiration. Okay, now let's look at the fifth property. The fifth property we must understand is high heat capacity. High heat capacity. What is heat capacity? Heat capacity is specific heat capacity rather. This is high specific. It is specific, okay? So specific heat capacity is simply the amount of energy, okay, needed to raise a temperature of 1 gram of a substance by just 1 degree Celsius. So water has a high specific heat capacity, meaning that it needs a lot of energy for it just to for the temperature to rise to 1 degree Celsius. Now, what is the importance of having high heat capacity? Okay, what is the importance of water having high heat capacity? So, the importance is that it is able to maintain a constant what? Temperature of a substance or of an organism. It maintains a constant what? Temperature. For example, our bodies are made up of all organelles. Okay, our bodies are made up of maybe enzymes. Okay, those enzymes operate at certain temperatures known as the optimum temperature. So water, it having high specific heat capacity, is able to maintain a constant temperature of that environment, and it heads in what is known as homeostasis. Okay, it aids in homeostasis. What is homeostasis? Homeostasis is just the maintenance of a constant internal environment. The maintenance of a constant internal environment. That is basically homeostasis. So high specific capacity helps in homeostasis. Okay, organisms are able to maintain moderate or constant temperature due to high heat capacity of water. Now imagine if water had a low specific heat capacity such that even a small amount of heat can change the temperature of water maybe by 250 degrees Celsius or 280 degrees Celsius. Okay, you discover that the enzymes cannot operate well at that high temperature. So the enzymes will become what? Denatured. But again, if just when heat, so much heat, a little heat, I mean, is removed from maybe water, then water drops, maybe the temperature drops by maybe 20 degrees Celsius, and just, by maybe amount of heat, energy, let's say just 5 kilojoules, okay? 5 kilojoules of energy, maybe 5 kilojoules of energy applied, then the temperature drops suddenly to maybe to 2 degrees Celsius. The water drops by a large what? By a large range of temperature. This will cause the enzymes to become what? Inactive. There are certain enzymes which cannot work best when the temperature is too low. Enzymes operate well at what is known as optimum. They operate well at optimum temperature. But when the temperature is too low, they become inactive. and when the temperature is too high, they become what? Denatured. So that's what you need to understand about high specific heat capacity of water. Then let's look at number 6, property that is known as high latent heat. So water has a high latent heat, but this latent heat we are talking about is the latent heat of evaporation or latent heat of vaporization. Okay, what is latent heat? Latent heat is simply the ability or the heat energy rather required to change the phase of a substance. Okay, heat energy required to change the phase of a substance or to change the state of a substance, for example from liquid to gas or to vapor. The amount of heat energy now which will be required to change this substance from liquid into gas, that is what is known as latent. Okay, latent is a term, a Greek term which means, or Latin rather, term which means hidden. Hidden. So if you have this curve, let's say this is the heating curve, there's latent here. Okay, there's a hidden temperature. The temperature can be changing slow gradually, but you can't notice it because it is hidden. Okay, but it seems to be what? Constant. That is what is known as latent. There's a change, there's a shift which is taking place, the change of state taking place, but you can't notice it. That is latent. So what does a latent, high latent heat of vaporization? Now how does it help? It helps in cooling. Okay, we are able to cool because water has high heat, high latent water heat, okay, of vaporization. How does it help in cooling? For example, you are there, maybe running, okay, you are running, then you sit. Of course you have sweat, okay, you have sweat, but because of water having high latent heat of vaporization, when those high energetic molecules of water in the sweat, when they evaporate, they'll be able to carry large amount of heat. Okay, they'll be able to carry large amount of what? Heat. When those molecules in sweat evaporate, they'll be able to carry large amount of heat and they'll leave your body cool. So that is how high latent heat of vaporization is able to help keep your body cool. Okay, then let's look at another property. Okay, another property of water. This will be number 7. The other property of water is what is known as high melting and boiling point. You see, many of these properties, when you talk about surface tension, water having high surface tension, when you talk about water having high melting point, it is because of these hydrogen. You're just talking about hydrogen bonds. Nothing much but hydrogen bonds. Most of the properties are as a result of hydrogen bonds. Okay, the attributes of hydrogen bond. So it is just hydrogen bonds which contributes to all these properties. So water having high melting point and high boiling point, it is because of the hydrogen bonds. These hydrogen bonds are, when it is just one, the hydrogen bond is a weak bond, but because hydrogen bonds in water there are many, this is what brings about water having high melting point and high boiling point, because when there are many, hydrogen bonds become more stronger. Okay, so you need a lot of heat in order to break these hydrogen bonds. And you need to remember one thing, that when hydrogen bonds, or when water is melting, okay, when water is melting, or when water is changing from liquid to gaseous, it is evaporating. Hydrogen bonds are the only bonds which are what? Broken. Okay? Hydrogen bonds are the only bonds which are broken. But when you talk of covalent bonds, covalent bonds are not broken. It is only hydrogen bonds which break, and covalent bonds are not broken. Okay, so let's look at another property which we are calling property number 8. Let's look at density. What is density? We say density is simply mass of a substance over the volume. Okay? Actually, the symbol for density is a rho, like that. So density is simply the mass over volume. Okay? And let's look at the relationship between density and volume. So the relationship is that density is inversely proportional to volume. When density increases, volume decreases. And when density reduces, volume increases. Now let's look at how density relates to the property of water. Okay? How is it that density is a property of water? I'll give an example of a sea here. You have a sea or a lake, and in this lake there is let's say there is a fish there. Okay, that is a fish. Then the environment is very cold. Let's say it is in June and it is freezing. Okay, it is very cold. Now how is it that the fish in water is not able to die? You see, when it is too cold, the enzymes become inactive, so an organism can easily die, okay, due to that coldness, because the enzymes are not operating, they are inactive, so a fish can easily die. Now how is it that a fish is able to stay alive? This is due to anomalous expansion of water. You see, water has high density at 4 degrees Celsius, but when the density is decreasing even in less than 4 degrees Celsius, approaching 0, okay, when the density starts to decrease, okay, when the temperature water has a high density at 4 degrees, but when the temperature gets to decrease even from 4 degrees approaching maybe 0 degrees Celsius, the water starts to expand. Okay, when the water starts to expand, the moment the water is reaching 4 degrees Celsius, of course at 4 degrees Celsius, that is the freezing point, so it will start forming ice in this water. Okay, water starts to form ice because the temperature is approaching at 0 degrees. That's a freezing point. But how is it that the fish is able to stay alive? So this is it. So what happens is that when the temperature is approaching 0, this ice starts to form in the water. Okay, but because when the water is decreasing in temperature up to 4 degrees, from 4 degrees to a lower temperature approaching 0, the water starts to expand. So due to that expansion, when something is expanding, meaning that the volume is what? Increasing. And from this formula, we said density is equal to mass over volume. So when the volume starts to increase, the density starts to reduce, and because of the density becoming reducing gradually, the density becoming less and less, the ice starts to rise, so it rises to the top. Okay, you see those ices now, these ices now rise to the top. Those are the ices on top of water, so on top of the liquid water. So this liquid water now is shielded by this ice. Ice acts as insulators. So when they insulate the surface, meaning that the environment or the temperature in water will be at least kept constant. So there will be no large fluctuation in the temperature of water because the ices have shielded this water. You get inside, and the fish is now able to swim, is now able to stay alive because of the anomalous expansion of water. That is known as anomalous, which is abnormal. Okay, something anomalous it is not normal, it is abnormal. Instead of something, when it is freezing, normally we know that when something starts to freeze, okay, when something starts to freeze, it should do, or when something starts to cool down in temperature, it should do what? It should do contract. When something is cooling, it should contract. But this is not the case with water. Okay? With water, it is abnormal. It is opposite. Instead of the moment it starts to cool, instead of it contracting, it starts to expand. Okay? That is anomalous expansion of water. So when the temperature gets lower than 4 degrees Celsius, the water molecules starts to expand instead of what? Contracting, and hence increasing the volume and reducing the temperature. So the ice is much less dense than liquid water. When you have ice, it is less dense than liquid water. Okay? Now let's get to understand something here. Let's get to understand something here. So I'm going to erase this so that we look at the other property of water which we need to know. So the other property of water which you need to know is the polar nature of water. So this water, this will be property number 8. This water is a polar solvent. Okay? Why are we saying so? Water is a polar solvent because it is able to dissolve polar substances. Polar substances can dissolve only in polar solvent. Okay? Polar substances can only dissolve in polar solvent. And literally, it is believed, or theoretically, it is believed that water is a universal. Okay? It is believed that water is a universal solvent. But that is not true. Okay? That is just a literal understanding or a literal theory. Okay? It's just a theory that water is a universal solvent, because there are some substances which do not dissolve in water. For example, the fats do not dissolve in water. Okay? Oils do not dissolve in water, but it is called to be universal solvent because it is able to dissolve many substances, okay, than any other liquid. No wonder water is said to be a universal solvent. And what's the importance of this universal solvent of water? It is able to become excellent in transportation. It helps in transportation system, because a lot of substances are able to dissolve in water. A lot of nutrients, oxygen, carbon dioxide is able to dissolve in water. These are able to get transported. Okay? Because they do what? Dissolve. They're able to dissolve and they're able to be transported in water. Is that so? That's be clear. Okay, so that's what we need to understand. The universal solvent of water is because it is able to dissolve many substances and transport them. Okay, so when something, for example, sodium chloride, this is salt, the water is able to dissociate this sodium chloride into its ions, like sodium ion. It is able to dissociate this into maybe sodium ion and the chloride ion. Okay, and when they dissolve, when they get dissociated, this chloride ion, when you look at water, let me rub this. When you look at this water, okay, the way the water is, there is hydroxide ion which are negative charge and hydrogen ion which are positive charge. So this hydrogen ion will get attracted to the chloride ion. This sodium ion will get attracted to the to the hydroxide ion, because negative charges, opposite charges do attract. So a positive attract to negative and the negative attract to positive. So the hydrogen ions get attracted to chloride ions and they are able to be transported, and also the hydroxide ion gets attracted to the sodium ion, and in that case they are able to bond together to get attracted, and sodium chloride is able to get transported. So basically that is what you need to understand there. Then the ninth property, the last property, is water is a medium of what? Cellular reaction. So you get to understand that a lot of enzymes, a lot of substances are able to dissolve in water, and most chemical reactions occur in aqueous. Most chemical reactions occurs in aqueous condition. Okay? And for that reason, we are calling water to be a medium for most chemical or cellular chemical reactions. Okay, because most chemical reactions occur in a medium where there is water, because they require them to dissolve. For example, I can give an example of this structure which is found in the lungs, the alveolus. Okay, so we have oxygen there, carbon dioxide going out and oxygen entering. Now there is something which happens here for this oxygen to get diffused into the pulmonary vein so that it can be transported to all the parts of the body, and carbon dioxide for it to get diffused from the blood into this alveolus so that it can get out of the body. There has to be something. There have to be water. Okay, there has to be water or moisture. Okay, they has to dissolve in what? In moisture. So there should be moisture for them to dissolve. So water plays a vital role in most chemical reactions. Okay, because even products of biochemical reactions are able to occur in aqueous. Okay, biochemical reactions are able to occur in aqueous environment. When you're talking about biochemical reactions, these are chemical reactions which occur in living organisms. Okay, in living organisms. So basically this is what you need to understand about water. In the next part, for part 2 of the video, we'll answer now questions on water and its properties. But for now, we have done with the topic water and its properties. Thank you for watching. Have a blessed day.